Hi guys. For today's introduction to lesson 3 of unit 1 about engineering and technology, you're actually going to have 2 assignments in HMH. You're going to have the introduction, and then you're also going to have lesson 1 or exploration 1. So I've logged into my son's HMH account. So when you click on assignments, you're going to have one that says how do engineers test and improve prototypes, exploration 1, and the other one's going to say how do engineers test and improve prototypes. So this one right here that doesn't say exploration 1, that is the introduction. So you're going to click start. Make sure you have this video running and your book open at the same time. So how do engineers test and improve prototypes? So we have a picture here of a crash test dummy, and they are testing a car. We have the engineer who looks like they are taking some data down from maybe a test that they just ran. So let's read what it says. Crash test dummies test what happens to humans in car crashes. Since the 1950s, the dummies have gotten smarter. Some early dummies were much smaller than average humans. Others didn't collect good data. Testing and redesign have made today's crash dummies more effective than those in the past. So now you have a video, and what I want you to do is to pause my video, and then you're going to play the video on here. So that video, early rocket designs often failed with their first test. They ended up with crashes and fiery explosions. Future designs were improved to solve these problems. So let's come on down here. How can collaboration and communication lead to improving your hearing enhancing device prototype? Enter your answer in the space below. How can collaboration and communication lead to improving your hearing enhancing device prototype? So collaborating means you're working with other people, and communication means you're talking about it. So think about doing group work. Would you rather do work by yourself, or would you rather do group work? Sometimes people enjoy doing group work because maybe you're stumped on an answer, but your partner has an idea, so then they can share their idea and you can add to it, and then you're collaborating. But if your partner tells you the answer and you write it down, that's called cheating. So collaboration and communication can lead to improving my hearing enhancing device prototype by sharing ideas and adding to previous ideas to make new and improved prototypes. All right. And then we're going to slide on down. Don't worry about doing the evidence notebook. By the end of this lesson, here's our I can statement. I can collaborate to improve my hearing enhancing device and determine a design that works best to solve the problem. All right. So that is the end of that lesson. So we're going to click the X here, come back here, then you'll click I'm done. Now we're going to start exploration 1. So you're going to click start, and we're going to work right through this. So exploration 1 is called Things Fail and Improve. Exploration 1, things fail and improve. Try again. You've learned that engineering solutions are designed and built to solve a problem. Often, perhaps, like what happened with your hearing enhancing device, a first design doesn't work. For example, a design might work okay, but testing suggests that it can work a lot better, or the design might meet all of the criteria but be unsafe. So we got to remember it's got to meet all the constraints and most of the criteria. The constraints are the important part. When this happens, engineers head back to the drawing board to improve their designs. Designs can also improve bit by bit as engineers learn more about the materials they're using. Small positive changes build up as engineers test and add them to the design. So again, you're testing your prototype and you're going back and changing it. Those of you who have been here in person last week, we did the buddy dropper, and you had to go back and you changed your design, you improved your prototype, and tested it again. And then you can do more improvements every time you test it. Just small changes. Remember, we don't want to change a lot at a time. The end result is the ideal or best design possible within the constraints of time, materials, and budget. So, if you're at home and you would like to do this at the tissue rope, that is something fun you can do. You can read through there and do it with them, but we're going to skip it and come on down to Kate's Done Right. This section always makes me think of the show Nailed It on Netflix. I love that show. I would be the person that has the ugliest, most horrific looking cake ever. So, Cake's Done Right. Engineers test their designs many times to get the best solution. Tests help them figure out what went wrong and why. This process is called failure analysis. It is okay to fail in the engineering design process because that means you can learn from your failure to make your prototype again and make it even better. Do some slight changes. It requires thinking carefully about causes and effects, especially for more complex devices or systems. So it says review the process of testing your hearing enhancing device. Use your testing and results to complete a failure analysis on your solution. So we're not going to do this because we really did not make this. But when you do a failure analysis, you're going to say what didn't work, why do you think it didn't work, how can I fix or improve it, and how critical is it to fix the solution. So is it important that it gets done? So we're going to skip that part. So come on down. Engineers improve designs by careful testing. One system part at a time. They don't change everything. They're not going to test everything at one time. They work this way to zero in on an ideal solution for a given criteria. The best bicycle, the clearest window, or even the best tasting cake. Read below about recreating Grandma's famous yellow cake. So here we go. This is called Too High, Too Low, Too Dry, Just Right. It's like the Goldilocks and the Three Bears. Let's look at the test bake pictures and the information for each test cake. Then write in the likely ideal recipe choices below. So let's see. We have a picture, a description, and then we have an observation. All right. So it gives us the question. So here we go. You're trying to match this cake's taste and look. Based on the test cakes, what are these recipe details? Okay. So let's look. Let's go on down. This test cake tastes about right. So let's talk about this first one up here, okay? So looking at it, how can we describe it? It's medium height compared to the other ones. It has tiny, I'm just going to type in it, medium height, tiny, it has little tiny holes inside of it. If you look, like those are teeny tiny compared to those. So tiny holes. It's it's not too brown. Moving on down. All right, let's look at our second one. It says this cake test tastes about right. It has 3 teaspoons of baking powder to make it puff up. It baked for 30 minutes at 350 degrees Fahrenheit. How does it compare to the ideal cake you're trying to match? Well, in comparison with that cake, it is taller and it has larger holes inside of the cake. So still the same coloring, but those are the two major differences that I see. All right, let's go down to the third one. It says this test cake also tastes okay, although it's a little chewy. It has 1 teaspoon of baking powder. So this guy up here had 3, this one has 1. And baked for 25 minutes at 350. So we have the same temperature but didn't cook it as long. How does it compare to the ideal cake we're trying to match? Well, it's shorter. And I don't see any holes at all. Those holes are what make it fluffy and delicious. Okay, make it rise. All right, last cake. This cake tastes about right. It's dry and crumbly, though. It baked for 35 minutes at 350 degrees. So it has the same temperature, but it's cooked longer than these two. It has 2 teaspoons of baking powder were used to make this cake. How does it compare? So let's look. I'm going to scroll from here up to there. So as far as height, it's the same height. It has small holes, but it's dark brown. All right. So based on that, we know that 350 degrees is the temperature. If we do 25 minutes, it's like this with 1 teaspoon of baking powder. This has 2 tablespoons of baking powder, but cooked for 35 minutes. And this one has 3 tablespoons of baking powder and baked for 30 minutes. So let's think. So we're going to use how much baking powder? I want it to be the same height. So the one that was the same height was this last one. And they used 2 teaspoons. So I like that height. And they're going to bake for blank minutes. 35 is too much. 25 was not enough. And 30 baked it all the way through. Wasn't too doughy, wasn't chewy, and it wasn't dry and crumbly. So I'm going to say 30 minutes would be the best. So 2 teaspoons of baking powder for 30 minutes. And we got it right. So let's go on down. We're going to put it together. Most prototypes are blank. Perfect, imperfect, or easy to redesign. Imperfect, IM means not. So most prototypes are imperfect. When testing a design solution, it is critical to go through a blank analysis. So failure analysis, success analysis, or variable analysis. Well, the only kind of analysis that we've talked about was up here, and it was called a failure analysis. When you figure out what went wrong and why, that is a failure analysis. So we're going to click on that. This helps blank a solution. So going back and seeing what went wrong and why it went wrong, that's going to help you to detect, improve, or vary. So detect means define. Improve means to make better. Vary means to change. So I'm going to say that failure analysis is going to help us improve. So then I'm going to click check, and we have it correct. So that is all of Exploration 1. We'll click off of that. We'll go back here to HMH Ed and click I'm done. And then you'll go back into Google Classroom and mark that assignment as done. If you have any questions, please let me know. Have an awesome day.